let me introduce myself to you all. I'm Dr. Harsha-haptics. I graduated, I did my first degree in electrical engineering long time back. That was in 2001. After that, I worked in Maharaja organization. Finally, I was at Sirasa TV as the electrical and mechanical engineer. Then I thought of going for my postgraduate studies. So when I actually joined the industry, I did not want to go for postgraduate studies. When I joined the industry, I just wanted to work. So when I just graduated, I graduated with SEMA. At that time, that was my idea. So I wanted to be a practicing engineer. Then once I went to the industry, so it's not like today. So at that time, universities were closed for long periods, especially because we had a clash. So university was closed for a long time. Meanwhile, I completed my SEMA exams. So having completed that, I got my first job at Maharaja. So that I was really happy. But as as I as time passes, I was not really happy with the routine work. So I just wanted to take a break after almost 1.5 years. I wanted to change my field. So then once I look back, I did not have publications. My degree class is also not that good. So, but anyway, uh, I tried a lot. Finally, not really, but I did GRE exam. I passed it with very good marks. So finally, I got a full scholarship from the Japanese government to study in one of the top universities in Japan, Keio University. So I got my scholarship. Actually, I'm the first one to go out from my batch after having a full scholarship. So I went to Japan. I did my master's in robotics in Keio University. In the same lab, I did my PhD as well. I was there in Japan for 5 years. So during my 5 years, I completed my master's as well as PhD. Japanese government funded everything. So my undergrad was funded by the Sri Lankans, and postgrad is fully funded by the Japanese people. Okay, having said that, so then I returned to University of Morocco back again in 2008. Actually, I joined 2009 University of Morocco, Department of Electrical Engineering as a senior lecturer. So once I joined, so we didn't have much. Robotics was not there actually at that time. So we introduced several subjects. So when I did my PhD, robotics was completely new. Only control systems were taught. After that, so we introduced several subjects. So then after joining, I developed. So I'm the one actually who developed this robotics and control lab in the department. So then after that, I worked there for almost 7 years. In 2015, I went to Thailand to AIT during my sabbatical. So I was there actually almost for 3 years. So 2015 to 2018, I was there in Thailand, Asian Institute of Technology. 2018, I came back and joined Moratour. So I used to teach in this program, your master's program a lot. So I used to teach two subjects, one on automation and another one on robotics. But when I came back, I just started comparing. I couldn't help with that. So I started comparing the rest of the world with our master's program. Our master's program is good because you are taught. But that is the problem which I had. You are taught and the research quality was really bad. So I voluntarily stopped teaching at your course. So I did not teach. So this is the first time I'm meeting you. This is the first time that I'm doing a master's, even a lecture. Maybe in more to a master's lecture, maybe in 7 years, I guess. So I did not teach at all, but very recently, Professor Buddhika invited me again to do a small introduction to you on research. So that's why I'm here today. So discuss about research. Okay, please participate. Enable your mic and talk, right? So that's what we're going to do. Uh, today's discussion is about, so I guess you already had several lectures on research. So when it comes to research, so I think Professor Buddhika and Professor Udayanga Hempal might have done some formal lectures. So today it will not be a formal lecture. So I'm going to just share my experiences, how I became a researcher. That's the story. How I became a researcher, then how I enhanced my research skills. And this is my story, so that throughout this lecture I'm talking about my story, so that from that I'm going to convey some of the important messages. And finally, at the end of the lecture, so probably we'll be discussing about how to write a paper as well, so that once we finish everything, so we'll be discussing what is research and so on, and finally we are going to discuss how to write a paper. By the way, so first of all, we'll start with okay, let me share a screen. My handwriting is not that good. Why we do research? I think you have already gone through all these lectures. So that therefore I will not ask directly questions, because it's a trivial question, foolish question, right? Yes, it is. And but maybe your answer might be what? Get your degree, right? What else? What else that you think? So for me, when I graduated, even I did not have a clear idea whether I should uh, do research to get a degree. At that time, that was not there in my mind. And the second thing that we normally do is we want to be, let's say, be a specialist. Spellings, yeah, spelling is wrong. That's okay. Be a specialist, and so what do you mean by really a specialist? So I'll elaborate on that. Number three, show your colors. Okay, so these are the stuff that I want to elaborate. Anyway, for most of the degrees, especially in okay, I guess the network is. I will stop the video now. Now I think you can hear clearly. Uh, now, in order to get your degree, you have a very small degree requirement when it comes to research. It's a it's a subject actually. It's a very small credit load. How much is your credit load when it comes to research? Is it 6 or 10? Any idea how much is the credit load that you have? How many credits worth of your research thesis? Even I don't have idea, because that's what I told you. I'm coming back after a long time. No responses? You should know how much is your research worth, right? So okay. Anyway, if you want to get your degree, so in there are different types of degrees. So you are level of feedback. That's good. 20. Okay. right? So there are degrees. So there are fully research degrees. For example, a PhD would be 100% research. My PhD is 100% research, and my master's is also almost like that. My master's, it's 95% research. 95% research means it's in Sri Lanka we call the MPhil degrees. It's 2 years, 95% research, 95% it's full-time research. So I had to do only two subjects. Even now in Moratuwa, we have MScs going for 1 year full-time research. That's also there. It's even though you say full-time research, it's also 80% research. 20% you have to do I think one or two subjects. So that's how it is. So, and in your case, it's even less. It's not that big. But in order to get the degree, so we'll be assessing. So not me, but other lecturers whoever the one who's assessing you all will be assessing your degree and will be assessing your research outcome to give it the degree. So in order to do that, we should know why we do research. So number one, as I told you, in your case, it might be just to get the degree. That's fine, okay, and be a specialist. When it comes to the research world and the rest of the things are a little bit different, because we used to. So when I graduated, I had a friend of mine who did BSc engineering, who did SEMA, who did low entrance exam as well. Not low entrance, I guess. He did some, I don't know exactly. So he had a qualification like this one. So now he's a barrister in UK, and he had some parallel qualifications like this. So when I graduated, so this was the normal idea that we had. So that's about to have so many parallel qualifications like this, and then you will be better employable in the industry. So that was the idea at that time. Now also that phenomena is there, but once you are doing research, what we really do is you are building up a cone, right? You are building up a cone. So this may be your BSc, this might be your likewise. As you go on to the top of this ladder, so you will be a specialist in a very small thing, very small thing. For example, I have been to Nissan factory long time back, which was 2004. In 2004, uh, so I was not allowed to go everywhere, but I visited one of their research facilities. In their research facilities, there were four PhD holders. The main job was to design a lock. The lock means the door lock. The door lock mechanism like this, so that you open the door, which is in the car. So that door lock mechanism, in order to develop that door lock mechanism, there were four PhDs. They are full-time researchers, basically developing this. That's it. So as you go on, you will become specialist. So if you want to become a specialist, you have to do research, because the knowledge is very much limited. But that's the difference between engineering and medicine, for example. In medicine, what we do is, so researchers or sometimes engineers make hardware, and they build a huge knowledge base. So there are thousands of chemical companies, pharmaceutical companies. They make drugs. They do drug discovery, and then finally they test it. Finally, there'll be a big database, right? There'll be a big database. So what doctors are doing, they will learn from this database. What do they learn? They uh, they learn about input output process. What are the inputs? Diseases, or what I say is symptoms, right? And if you give for these symptoms, so there is a database for these symptoms. You relate to the database and you just give a drug, and once you give that, you will be cured. So it's a system like this. So once you have a database, their learning system is basically to memorize this database. So don't you think in the future this type of uh, knowledge or this type of database application, it's fairly database. And of course there are differences. For example, if you want to do a surgery, there is a part of skill, of course that's there. But most of the time, so things are like this, inputs and outputs. So I'm not really talking about this type of a research. So this is not a research. So you just refer to this and you get the knowledge and treat the patient. This is not research at all. So but if you want to become a specialist uh, here, right? If you want to become a specialist, what you need to do is you need to concentrate on smaller things. But finally, once you become a specialist, there is a danger. The danger is when I went to Japan as a research student. So we were taught electrical machines, electrical power systems, and so on, lot of things. But when it comes to Japan, so their students, they are very much focused, very much specialized. So, but a train specialist might know a train. So, so those engineers who work in with trains, they know only about their locomotion and their motors and controls. They don't know much about the power system. So that is the method that we the rest of the world is using. But in Sri Lanka, we used to work with this type of knowledge base, not this type of knowledge. So the advantage might be, of course, so you will become a top, or you will become a specialist in your field. But the problem is you might not know so many other things. So that's why research is good and bad, especially when it comes to in Sri Lankan context. So what I mean by this, be a specialist, means when you, for example, my advice, when you present your thesis at the end of your course, right? You might be presenting your thesis, you might be having a defense. In your thesis defense, you should be the best person to explain your research. It's your baby, so you should know about it, and you should be able to elaborate that, and you should be having a understanding such that the rest of the panel should not rest of the panel, and including my supervisor, they do not know that than me on my subject. I will repeat, you should be having an idea that I know what I am going to tell, what I'm going to talk, than my supervisors or the rest of the panel. You should be having that confidence, so that you are studying a very small thing, that's fine, but you should be thorough on that. Then you are okay. For example, I in my PhD I proposed a very small thing, so I cannot elaborate that right now. I proposed a very small thing, but in Japan, for example, when I was just about to present my PhD thesis, my supervisor, having a mic in his hand, he just said, I'm going to present Mr. Harsha-Haptics, and he's the one who invented this. And he elaborated that, and he presented me to the rest of the world and said he is the one who invented this and this. And it's a very small thing, so it's okay. You might know a very small thing, that's fine, but then that's how the world grows. Okay, so in order to when the knowledge grows, that's how it goes. Okay, show your colors. Number three. This is where I am now. So I have taken the degrees. I have become a specialist, I guess. and show your colors. So once you have received degrees on everything, then you are finally you will come to this stage. So where for example, if you take PhDs, so in our department everybody is having a PhD. So then how do you differentiate from person A to person B? So then there should be a performance criteria. Of course, there are now in Sri Lanka, there are bad performance criteria like what you do with your administration and so on. But I'm not talking about Sri Lankan system. I'm talking about the international system. When it comes to international system, if a researcher A and researcher B is there, so how do you compare these two fellows and say which one is superior? Normally, don't you talk? කතා කරන කට්ටිය නෙමෙයිද? So how do you really differentiate these two? Okay, no responses. I'll continue. Okay. Uh, Now, if you want to compare the person A and B who are researchers, so maybe the success of maybe we might be measuring number of patents. Let's say number of patents. Right. So number two, number of patents. Of course, when it comes to Sri Lankan academics, we don't have much patents. But if you are a researcher, you can have a patent. So patents also, there are different tiers. You can have a Sri Lankan patent, you can have international patent and so on. But why do you have a patent? Once you have a patent, you can sell it and get money. So I'm not really targeting that level, but I just wanted to say that in order to complete this. So after that, we in academics, or even for you, for example, if you want to get a PhD scholarship and so on, one of the best method of showing your colors is to have a paper published, right? So that is what I'm going to explain or elaborate today, how to get a paper published and how why you should do research, how you should do research. And so then the next point is, how do you compare these two persons? So number of papers. So when you want to compare number of papers, so papers also, there are different types of papers are there. You might not know much, but there are what you call journals. So journals are there, conferences are there, conference papers are there, right? Pen is not working well. Okay, number two, I'll rewrite. Conference journals are there, conference papers are there. Number three, there are book chapters that you can write, book chapters or books. Okay, so initially people thought of, okay, I'll explain a little bit. When it comes to journals, there are good journals, bad journals. How good or bad journals are, that's depending on how good these journals in contributing to the research. If you write to a journal, so a journal is having a rating. Journal is having a rating. That rating is called impact factor. That rating is called IF, impact factor. So that if you have a very good journal, in that journal it is very hard to publish a paper. It's called a high tier journal. So that if you look for a journal, think about its impact factor. If the impact factor is high, so it's prestigious for you to publish in that journal. The easiest one to publish is conferences. So conferences are also, there are different types of conferences. For engineering, we usually used to publish in IEEE. IEEE conference are there. You can go to IEEE website and there is a conference search, for example. These days, you don't have to physically visit there, but you have to pay money and get it published. There are, for example, in Moratuwa, there are 2 or 3 conferences fully IEEE, which you can publish just for 15,000 rupees. So if you have your research outcome ready, you can get it published, so that if you have enough papers, that's a good method of showing your competencies to the rest of the world. Because if it goes to the IEEE conference, IEEE website hosts your paper so that others can also see. So that's a good addition to your CV, so that once you add these to the CV, you can elaborate that, and you can say, you can claim that I have done this to the rest of the world. Most probably, for example, our students, our research students get postgraduate opportunities by publishing. Once they publish, so it's a good opportunity for you to publish, do a publishable research. So then, so you're serving two purposes. What is the first one? First of all, anyway, you are getting the degree. And but if you published in a better place, it's good if it is in a journal, but at least in a conference, if you publish, you can get your CV rich, and by that you can uh, you can get a scholarship, for example. Okay. Now, person A and B are having these portfolios, so that there are journals, conferences, and book chapters. So this is how we normally say. So that finally, based on the number of journals, based on the number of conferences, chapters, also you can compare A and B. But then all these Indian and Chinese people started copying, and they just increased the number of papers. Just as for this namesake, there were lots of thousands of papers available in the market, available in the different websites, so that people wanted to differentiate A and B. So that in order to differentiate A and B, there are other factors came in. For example, if you go to ResearchGate website, for example, in my name, if you search in ResearchGate, or if you go to Google Scholar and search my name, there is a research scholar page coming up. In the research scholar page, it clearly shows per paper. For example, the first paper, this amount of citations means others have cited you means this paper have been used by the others research. So that means your paper is valuable. So that number of citations matters. And there is, so number of total citations is also a good indicator. So that's a sort of an impact factor is normally defined for journals, but for humans it's not an impact factor, but we say number of citations. So now when the number of citations goes up, that means your research is looked at and your research is used by the others. So that's a good indicator of yourself. So that if you have a paper and if your paper is referred by the others, that's a good thing. Okay. Then what it comes to my mind is, then you should be able to write a paper, number one, which is accepted by journals or conferences, so that you have to write it in a nice manner. So that's the first target. Prime target is, how do you get it published in one of the good places. So the second thing is, once it is published, you should be having an idea. Okay, once it is published, the paper should be accessed by the others, so that it is a marketing problem now. Okay, I don't have space. Okay, I'll finish that here. All right, number of citations is one, and nowadays there are new additions to this. Even number of citations, sometimes let's say you write something which is totally wrong. For example, I'm not really quoting Dhammika Penny. For example, now let's say there are a set of researchers who have done a research on this Dhammika pen, right? So they have done a preliminary study. So once they have done, I don't know whether they have published. If they have published, for example, let's assume that they have published that. Then once they have published that work, finally, if that publication was nullified by another publication, let's say at the second trial, the first result is wrong, so that for the first publication there will be lots of citations, because people just wanted to attack that paper. And in how do they attack? So without citing it, you have to cite it, and say this research is bad, so that if you say that research is bad, still the citation number goes up, so that there is a possibility that even for bad papers there may be a higher number of citations. So in order to stop that, now a new method has come up. So even people go for the citation comment. For example, I say uh, Abekon et al. Has, so if it is my paper, Abekon et al. Has developed a system which uses this method. So that is a that statement is a neutral statement. There may be positive statement. For example, Abekon et al. Has derived or obtained this mathematical model. So that is a positive statement. Likewise, even now scientists have gone to a stage where even the citation quality will be analyzed qualitatively, so that what the others say about your paper, your conference paper, your book chapter or journal. So that's about the paper. That's about the papers and the comments. So I guess I answered the question. So why do we do research? Okay, let's go to the next section as such. By the way, do you have any questions? Anything to discuss? Any comments? Any points that you don't understand or disagree? I'm open for discussion. Anyone? 24 participants. None of you talk, right? සාමාන්‍ය කතා කරන්නේ නැති කට්ටියක් ඉන්නේ. All right. Next, I'll discuss about selecting a topic. Okay, this is the topic now, to selecting a topic. By the way, have you all finalized deciding or selecting a topic? Have you all finalized the topics? At least chat. Put a chat message if you don't want to talk. Yes. Okay. Only one. Any others? All right. So, but
Yes, sir.
okay. But maybe I will just give you a rough idea how to select a topic. This is my personal understanding, personal experience. So that selecting topic is a very, very tough decision. So I know how difficult it is because I was also a student like you. So I'll first of all tell you my experience, and I'll tell you how to select a topic. Okay, my experience is, once I graduated, my first degree was in electrical engineering, but I wanted to do masters in robotics. Robotics was not taught, just the control systems was taught. I went to the lab. My supervisor, Japanese guy, Onishi Sensei, he's a really a good guy. Then on the first day itself, I just asked Sensei, can I have a topic to do research and so on? What he said was, no, no, don't worry. You just come to the lab, sit and go. So then I was really tensed because I go to the lab, I just sit, I cannot talk with the others because my Japanese was a little bad, and I cannot talk. How can I just keep uh, sitting for the whole day and just sit and go? So just like that, I was sitting, others are working. Then after several months also, I'm worried. I was really worried. 3 months maybe. I just asked from my supervisor, Sensei, what is the topic which I'm going to do? He said, no, no, you will select your topic on your own. Just come to the lab and go. That's it. So that was the instruction that was given to me by my supervisor. No topic was given at all. So that is the Japanese way. So they think that the real original idea should come from the student, not from the supervisor. So they normally ask the student to come up with a topic. So I was just staying there, just seeing others are working, they're getting results and so on. Of course, things induced to you, but still I was finding really difficult to decide on a topic. So what I did was, in order to select a topic, I started reading, right? I started reading what? Journal papers, conference papers, books, book chapters, and so on. And after reading a lot, right? So everybody, when I asked, what they say is, you read and see, read. I think you also might have got the same instruction. Read. Yes, I read a lot. uh, Almost for 4 months, 5 months, I read a lot. I have printed so many papers. I read. Once I read the papers, right, read the paper. So there are two problems which I faced. Number one is, of course, the topic is that topic looks attractive. That's why I read. That is what you call the abstract. That's what I'm going to tell. That's what I'm going to elaborate. Abstract is the one which is the marketing statement. Marketing statement means you talk about this. You talk about this, and so this is what is included in the paper. So that I read the abstract, and then I go to the content, right? Content, maybe introduction is there. After that, content is there. When you go to the content, you go to the content, right? When you go through the content, I find it difficult to understand. So most of the time, 80% of the time, there are lots of equations which I do not understand. I don't understand what they say. There are lots of mathematics I don't understand. So that 6 pages are there, in at least in the conference paper, but I barely read. Maybe I read only 1 or 2 pages. That's all what I read. So I cannot go beyond that. And luckily there were some papers where I found the paper is attractive. I can read until the end. So those papers I can categorize. So those papers which I can read up to the end, I can now categorize into two. So one are really good in the sense, which are very related to me, which where I am confident with my mathematics knowledge, I could go through it. So if I'm thorough with it, I could go up to the end. And there are some other papers. For example, if you search it in the web, there are so many Indian papers, not only India, in Sri Lankan and Pakistani and this region especially. There are papers where nothing is there. You just read it. You can read on, but nothing is there. They're just bluffing. You can read and you can finish the paper. So that part also I did it. So those are the two type of papers which I read. Others, very good papers, I had to skip because I didn't have the knowledge. But let's take the papers, good papers, where I read up to the end, at least. Maybe 80% of I understood, at least 80%. That's enough, right? Even don't so even if I read a paper today, even on robotics, I'm having a PhD in robotics, there is a possibility that I might not understand beyond 80%. Even sometimes it might be 60%. So because there are lots of so many things unknown. So even for you, once you read papers, you might not understand even more than 40%, I guess. That's totally okay. So, but after reading these so many papers, even which goes to 80%, what I found was you might be having this same idea even now. After reading this paper, the impression what I got was, okay, they have done this marvelous, but they have completed everything. So what can I do? That is the idea which I got. So they have done a nice paper. They have results, right? They have graphs. So everything is there. Introduction is there, abstract is there, everything is there. But once I finalized everything, there is nothing which I can do. So what I can do is just appreciate their work. That's it. Just appreciate their work. So then how can I select a topic? Because they write the paper in a way such that that's it. That is the end of the world, right? Okay, so then nothing to do. That is a dead end. So read finally ended up in a dead end. But nowadays, I have seen a lot of inferior type of papers are telling you at the end of the paper saying future works. These are the future works. These are the things which I'm going to do, or which these are the things which could be done or elaborated like this. I do not recommend. If you write a paper, I do not recommend that. You should also write a paper that this is the end of the world, right? The end of the story, because you have done something. You should not give free of charge research ideas free of charge, because if you are a researcher, you should do it. Do not give free of research ideas free of charge. Just stop it in the sense, don't hide anything, but don't give ideas also, right? That's a trick which is used in the papers. That is why I ended up with a dead end reading, right? And after reading I stopped thinking, right? Okay, selecting topic, the second method which came to my mind was just to get a feeling, just to get a topic from the gut feeling. I will write it as it is, gut feeling, right? Okay, from your gut feeling, can you get a topic? Yes, I'll come back to this. And the third option is, of course, the easiest one: get it from the supervisor. So nowadays, as a supervisor, as a researcher, now I used to give topics to my students, which is a little bit bad. Why I say that? It is bad because the students do not think, they do not go through this whole process. But for especially for master student, if they spend 6 months selecting a topic, it's a waste of time. So that I do not let them to do it. I do the literature review, and I give them the topic normally directly for my research full-time students. But this is a bad idea. So that normally if a supervisor gives you, you should ask what are the objectives, what are the deliverables, and so on. Everything you should ask from your supervisor. It's a little bit hard for the supervisor, easy for the student. Of course, that's a direct. Okay, second is from the gut feeling. From the gut feeling, how do you select a topic? So even when I was a master student, I had so many funny ideas. Funny ideas means I was supposed to do research on robotics. Now I was thinking about so many funny research ideas at that time. I'm talking about the technology which were available in 2004. No, 2003. In 2003, I thought my lab was actually working on haptics. I don't know whether you know the word haptics. My research area is on haptics. Haptics means the sense of touch, the touch sensation. So the lab is working on touch sensation, but I was thinking some things totally different. So let's take a human. These are the ideas which come to my mind. So he's a human. So can't I have a wearable hat? And from the wearable hat, can't I get probes? And from these probes, can't I mm, run a machine? This is already now it is implemented. This was my research idea. You are wearing a hat, and from these signals, this is called human augmentation. So that from these signals, can't you run a machine? That was the idea. That was the gut feeling which I got, which was completely new at that time. So it's a marvelous good research, isn't it? So no one has done it. So it's a good research, but then I told that idea to my supervisor. He said, no, 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 you cannot do it. That's it. So why? Because supervisor is also not knowledgeable, and we do know much, and this was completely new. So that from the gut feeling, if you have a research idea which is completely new, that is also not that good. Okay, for a short period of time, let me share my website to you. Okay, let me open it. Okay. By the way, this is my website, which I did, which I completed this while I was in Thailand as a uh, as an assistant professor. But once I came back to Sri Lanka, I did not update it. So still all the addresses, telephone numbers, and everything is from that. So this is the website. If you want to visit, it's harsha-haptics, harsha-haptics.org. My research area is on haptics. So there is a small introduction is there, as you can see here. So I just want to elaborate and show which I have. There is a photo, maybe this one. Robotics and haptics. Human is greater than robot, so there is a research gap. That's my theme. So human are having so many capabilities than a machine. So then there is a research gap. Of course, there are lots of scopes which you can think of. Human is really bigger than robot when it comes to haptics. Haptics is sense of touch. Just by touching an object, you can say that this is the object. So, but humans are having so many capabilities, and machines are not. So that there is a huge research gap. That's my idea. That's my theme, and that's my motto. But okay, now I'll share. I'll go back again. I don't know whether you are getting this or not, or whether you are feeling bad. And this is it boring, or do you want to listen to these stories or not? Do you want a formal discussion? Anyway, still no feedback. Right. So from the gut feeling, you can get this type of stupid idea. Actually, it's not a stupid idea, but it's a completely new idea where I don't have a expertise. Even my professor is not having such expertise, so that it should not be done in that scenario. So at 2004, if you think about this research, if this is what I proposed, if this is what I proposed, so chat message, let me check that first. Okay, at least one person is there who's interested in listening to my stories. Okay, it's actually not a storytelling, technical way of storytelling. Okay, right. So if you take this research idea, if this is 100%, this is 100%, right? If this is 100%, which you have to do, if you think about this, 99% of these were new, right? 99% of these were new at that time, new. Maybe people at that time, people might have detected uh, how to detect human brain signals using EEGs. That knowledge was there. So it might be just 1%, but how do you encode that 1% knowledge to make a system like this? This was my research idea. Now it is already being practiced not by me, but by the others. So it is 99% new. Of course, it's just 1%. It's already available. If your idea is something like this, never ever think about making this. I'm bad by saying this, but it's really hard to tackle a problem like this. It should be this percentage. New percentage should be at least, my guess is it should be less than 40, less than 40%. Otherwise, you cannot do it. Okay, from the gut feeling, there is another method of deriving a research topic. Of course, if you're working in an industry, if there is a research problem which you can solve, you can do it, but that is not called as a research. Those are called project titles, projects. So there is a clear difference between projects and research. The differences are in research, you do something novel. In projects, what you do is you do a project. When it comes to a project, things are more or less in routine manner. So I went through your some of your topics. I got the topic list from Professor Buddhiga. So most of the topics are not really new, and they are almost look like projects. So there is a difference between project and a research. It's good if you can make your topic a research rather than a project. So projects are, for example, I can say enhancing the, let's say I'm in my room now, enhancing the lighting levels of this room. That's a routine design. That's a project. That's not a research. Okay. Maybe I can say, uh, what is the effect of lighting if I change this bulb to LED? That's also not a research. Others have done it. So what you can do is you can change the bulb and get the measurement, and you can say that this is it, and so on. So there are so many project level of research. I'm not forcing you because this is a small component as such. Therefore, it's not mandatory for you to have a very thorough understanding on research. But I'm presenting about the rest of the world, not in Sri Lankan or in your context. Okay. From the gut feeling, there are some other ideas will come up. The ideas are, okay. From I had a childhood experience in my house. Uh, though I'm from Piliandala, so we had tractors, we had paddy fields, and so on. I used to go for plowing, and using my tractor. We had a tractor, two-wheel tractor. In the two-wheel tractor, so from the paddy field, so there was a little bit steep slope like this. So two-wheel tractor is having a trailer. So let me draw the trailer. Trailer was like this, and the two-wheel tractor is hand tractor, right? The tractor, two wheels are there. I'm really bad at drawing. Okay, there is one wheel, and this is how you go up, right? So you go up. I had a childhood experience when the two-wheel tractor goes on uphill. This starts to slip. This started slipping. When it started slipping, what we used to do was, right? This what we used to do was, if it is slipping with a load. Now this is the load. This is your trailer. The trailer was like this. If it is slipping, we used to move the rear side of the load to the front. Right? If there is a huge load here, there is a tendency of slipping a lot. So we move this load to the front so that when you do it that way, the slip reduces. Right? So that idea clicks all at once I was reading the papers in the library. This idea was nowhere at that time in the library. I was searching, reading. Now it was almost 6 months without having a topic. Frustrated, this idea came to my mind because I had this childhood experience. If the tractor is slipping, we used to move the paddy bags, Vigoni, from the rear end to the front end. So then the slip is reduced. What do you really do is once you move that to this, so the reaction force coming from the floor to this increases, so that based on that you can regulate the slip. That clicked my mind. So then I went to my supervisor and said, Sensei, so if a robot is slipping, can I increase the load acting on that wheel? If I increase the load acting on the wheel, will the slip be reduced? He said, of course, yes. So then can I do that as the research? He said, okay. Okay, that's how the gut idea, gut feeling, this childhood experience came to my mind. That's how I made my first master's topic. Okay, this story I did not tell to any one of my students yet. It's the first time I'm telling this. This is a very simple stuff. So my idea cleared up. Okay, but next thing is, maybe I'll erase a little bit. Now the idea was there. Since I said okay, you can go ahead. Then from the gut feeling, how do you create a research? That is the next topic. So now I am telling to my students, once you get a gut feeling, if you have a from the gut feeling, if you have a research idea, number one, very important thing. So this is very important, very, very important. Write it on a paper. Super important. Write it on a paper. So why I say that is, so you have to write your idea on a paper. And then now I said I had the idea of sleep regulation or sleep control. Then I started searching with the keywords. What are the keywords? Sleep regulation by robotic sleep, and so on. It's there in EVs and vehicles and so on. It's a fairly mechanical topic. So then sleep regulation, I started reading a lot of papers. So lots of papers came to me, and at that time there was a researcher, a friend of my supervisor, working in sleep regulation in Japan. So my research idea, actually I did not write this idea on a paper. I did that mistake. So then I started reading the papers. So my original idea, which I wanted to change the COG, by changing the COG, I wanted to increase the reaction force coming from the floor to the wheel, and then thereby I want to reduce the wheel slip. That was my idea, but that was not practiced. But when I started reading so many papers. When I started reading papers, what I got to know was, so others have done marvelous research. So then I had a tendency of, oh, my idea was really bad and others have done something good and they have algorithms. My method is not there. And maybe this may be the method. These are the research that I should follow. So that finally what I understood was, if you do it that way, right? If you, without writing your idea on a paper, if you start reading, after reading 10-15 papers, finally you will say your research, your idea is bad. I have a lot of students. They had, normally I give a topic. Once I give a topic, there's I ask them to read papers. They read papers. Once they read papers, finally they come to me and say, okay, so I read papers, but this person have done this and so on. All the enthusiasm, all the energy has gone out, because they say this is already done by this, right? So why I say to write it on the paper, maybe there may be a difference what you think and what others have done. Of course, it is really needed, essential for you to read papers and say, read papers. That's essential. Read papers and say, uh, your idea is new. But once you read papers, so you will find 90% of the things which you wanted is already done. So then by reading that 90%, you will use your interest. Finally, you will say, it is already done, sir. We nothing to do currently, and anything. That's it. End of the life. Okay. Then that's what I wanted to tell. We are actually searching for a research idea. Okay, let's assume that this is the research idea which you wanted to do for a PhD, not in master's level at least. So that what you should be looking is, you should be looking for this. What you should be looking is, you should be looking for 95%, 5%. All right, 95%, and this is 5%. Why I say that is, 95% of the things which you are going to do in your PhD thesis or in your research might not be new. This is already done. It's already done. That's okay. It's already done. But by writing your idea on the paper, by reading the papers, now you are in a position to identify this 5% your own, right? Your own 5%. This your own 5% is called, in research terminology, what do you call this? At least type. What do you call that? Contribution, right? Contribution or originality. That is the better word, originality, right? Uh, so your own 5% is your originality, so that your why you so you get the idea and write it on the paper, read papers. Why? So why you read papers, I'm going to tell you next. uh, so then once you have to identify what is already done. What is already done, maybe there may be algorithms, there may be methods, there may be mathematical derivations, modeling, everything might be there. So just read that in, so just understand that so just learn 95% which you want, and identify the 5%. Right now now I assume that you identified this 5%. Right, this is my method which I followed for my masters. For my PhD, actually, for when you are mm, good at research, right, when you are good at research, things will become super easy. For example, I know I spent almost 6 months taking this sleep regulation topic uh, for my masters. Okay, now, okay, now I'll show you. I will show you my paper. I told you the story, and this is the paper which I published for my masters. Right, traction force. Can you see this PDF?
Yes.
Okay, so it says traction force improvement of two-wheel mobile robot manipulated by changing the center of gravity. So I told you the idea which came to my mind, and if you read on, normally I don't ask my students to read this, but there is one full-time student is with me today. If you read, I'll be really embarrassed, because now I used to say lot of instructions, lot of things I used to say, oh, this is bad, that is bad, and so on. So if you read this paper, it's a very good thing to read, in the sense there are lots of thousands of mistakes. Now I can see, but I did it. I wrote this as a master student. At that time, I did not know. So you see lots of deficiencies now, but at that time this was the best paper which I can write. I was fortunate to visit the world. Actually, at that time my lab is having plenty of money. I wanted to go to Australia. I asked from my supervisors, Sensei, can I present this in Australia? He said okay, yes. He gave me the money. I wrote this paper and went for a trip. Actually spent 1 month in Australia and came back to Japan. So that was the motive at that time, just to travel. So the paper which I submitted, and I'm not going to elaborate on this paper. There are so many problems associated with paper. So this is a model which I usually say. So so this is actually a recursive process. Writing a paper, you will learn step by step. Even now I'm learning. So there are so many problems which I see today. Even if I read the same paper after maybe 2 3 years, I might say this is also bad. There may be different things which I wanted to say even from today. This is a recursive process, never ending process, learning how to write a paper. It's a difficult task, as I told you, but anyway, here is the paper. Okay, I'll stop share. So these papers are there in my website. IEEE papers are you are allowed to write put your papers in your own website. So I'm keeping my websites papers there. So if you're interested, go to my website and search. Okay, I wanted to show you another small area in my website. If you go, can you see my website now?
Still not, sir.
Okay, right. Now I'll go to my website. Now I think you should be able to see. Is it?
Yes, sir.
Right. So the things which I said are there in publications, but on experimental videos, I'm having a very small. It's a small thing. I'm having a small YouTube link, YouTube channel. I'm having 16 videos, mostly undergrad students work and AIT Thailand work and so on. Moratua students work and Thailand students work. And for example, there is a haptic rehabilitation. I'm not going for technical details. Thailand, so robot aided rehabilitation and tele-rehabilitation system. Okay, there are plenty of interesting stuff there. Okay, that's a little bit. Okay, I'll show you another one and go. That was a master's one, which I said that's a little bit too technical. I'll show you say two videos out of these and go. Number one is okay. Let's show this. All right, this is undergraduate project 2012, I guess. Okay, what he's doing is he's making a sound. So once this sound is emitted, that will be picked up by, there is a triangle. As you can see there is a triangle. So in that triangle there are three mics. So three mics picks this noise, and from that there is a path difference from this point to that point, and that calculates back where the sound was originated. Based on that, robot goes to the point where the sound was originated. That's what it's happening. Now it stops exactly. Now the person is making sound from the other end. Let's see how it moves. Okay, now the sound was emitted. Now the robot goes and exactly stops at the point where the sound was originated. So these are undergraduate simple project. All right, another one. I just wanted to show and go, but yeah, okay. This is the last one because I had to talk about on the topic. This is also undergraduate project. We made a haptic based walking stick. Walking stick can heramitia. So this walking stick is it's very simple, very simple. This was considered this was selected as the best project in Department of Electrical Engineering at that year. This is we tested this at Blind School Ratmalana. So it's having several ultrasonic sensors at your fingertips. There are three vibrators taken from mobile phones, so that the vicinity or the nearness or the proximity to the obstacles will be translated in terms of vibration to the person, and left side, right side and front will be sensed. When the obstacle is nearing to you, you are getting a higher level of vibration frequency is high. The student is completely blind. We ask him to walk without tapping and without colliding this. This sort of actually very good, very good device. We place the batteries there in that pole. Now you see he's walking without colliding. Okay, so finally, once this was finished, I showed this concept in Sri Lanka, so for in different forums, but no one picked up. So I showed this video in a public conference in Thailand. There was a company happy to develop this, but I came back to Sri Lanka. So, but now I am not really dealing with it. We have the technology. It's very simple. It can be used. Okay, that's it. Having said that, we'll go back to the original whiteboard. Okay. Now, right. Now we will, I'll clear this up. By the way, do you get a break from the other lecturers? Now we have spent 1.5 hours almost. Do you get a break or not? No break, right? You're automatically getting breaks, right? You can eat at your home and so on, right? Do you want a break? Normally others will, do they give a break or not? No breaks, it goes at a stretch, right? Okay, I'll also do it. Okay, next, what I want to tell is now we are going towards the paper. So I'm roughly telling you how to write the paper. Okay, before going to the paper, I just wanted to discuss about the idea. Now I will redraw that circle and say now I'm having 5% which are really new. Let's say which are really new, and this black is 95%. These are already done. It's already done. These are not new, right? Not new. So, but this one, this 5% is new. This percentage might be different. So sometimes you might even go for 60, 40 and so on. Initially I told you don't develop so if it is 60, 40 is okay. Even if it is 50, 50, do not develop. It's very hard to do such a job. 60, 40 is okay, barely okay if it is a master's level of a project. Now, if I assess this percentage for my master's, it was fairly new. I can say 70, 30. For my PhD, it was 60, 40. But I have never tried 50, 50 ones because these are very difficult. So you should majority of the things which you wanted to do, you should be able to get it from the literature. That's why we read the papers. Now by reading the papers you should be now very clear that this is completely mine. So this part you should be very clear. I have seen a lot of master students making presentations. So when I ask what is your contribution, or the correct word to say is what's your originality, so people should say that others have done this but they have not done this, right? So you should be able to elaborate this 5%. So, okay. So when it comes to a paper, now we are writing a paper, right? So this is the research idea. This is the total thing. This 100% is the total thing which you have to do in completing the thesis or in completing the project. So 95% of this is already done, and 5% of this is already is fully new. So when it comes to a paper, how do you translate this to a paper? Let's say I'm going to write a paper, or let's say abstract and so on. Everything I'm going to explain now. So in your paper, about this 95%, you should write only 5%. About this 95%, you should write only 5%. About 5%, you should write 95%. Is this stupid? No. And now you should be having a topic for this. That is the research topic. So what do you think? Number one is, how do you put a topic now? How do you put a topic? That's also a very tedious process. How do you put a topic to your, now research idea was clear now. How do you put a topic to your research idea? That one, so there are several options. One is you can, let me take another color. You can put a name, you can put a title, which covers everything. Which covers everything. This is one option. This is red color. Okay. I'll take another option. Right. Green color. Green color. Number two. Number two, you might talk on. You might put a name uh, which you talk about this 95%, right? 95%. And number three, change. Number three, you put a name, right? I'm talking about this name, right? I'm putting a name reflecting this 5%. Which option should you choose? Option number 1, 2, or 3? You want me to repeat? What I said was, now you are supposed to put a topic now, right? So how do you put the topic? Should it cover the total 100%? Or should it cover the 5%? Or should it cover 95%? This is the question. Now I said in your paper, 95% of your paper should be written about this 5%. 95%, 5%. So that's hard, is it? No. That is what you should be doing actually when it comes to a paper, when it comes to a proposal also. Now you are writing a proposal. When you are writing a proposal, I'll elaborate that part. Now, how to write a proposal, how to write a thesis. So this is also applicable for your thesis as well. What you would do. Okay, what's your options? Can you answer now? 1, 2, or 3?
3.
Okay, 3. Any more? Any other ideas? Yes, I also feel that 3 is the option because that's your novelty, right? So once you write a paper, once you write about the topic, okay, now I will share. Again, I'll go to my papers. All right, so I'm going to my publications. I hope you can see my web page now. Sorry, this is not updated. This is not updated for so long, but it's okay. Let's see. Now see 3D environmental force position variations for different motion parameters. This is completely about 5%. See simulation of active suspension, active vibration suppression using internal motor sensing. So the what exactly says about the topic. You have to do it you have to do the same. Normally I put right. So I'll tell about a little bit different one. Yeah, different one. Okay. You might not understand much, but this is a book chapter. When it comes to a book chapter, you don't go for very detailed specifics. When it comes to a book, it should be overall. So this is a little bit broader topic, but you have to put a name as narrow as possible. So right, this is a fairly a broader topic: sound localization, human versus machine. Here, the student is Nuanja Avery is a full time. He's like you all. So from automation group. So what we did was actually it was a really interesting thing. So machines now I already showed you how machines localize the sound, and now the robot moves towards the sound. But humans also can say that sound. We can say where the sound was originated. But what is the algorithm behind your mind, behind your brain? We never know about that. So what we did was we had several models which are there for machines. So then we blindfolded about 40-50 people, and we tried to match with different frequencies and so on. We try to predict that what is the algorithm which is working in a human. So that was an interesting thing. It was a little bit broader topic because sound localization human versus machine. So that we cannot go a little bit deeper because the topic itself is like that. But other than that, see topics are sensorless control, contact position estimation of a mobile robot in pushing motion. So I exactly say what it is. It is a very basic, simple paper, disturbance observer based current control of a brushed DC motor. Okay, I'll open that. I don't know whether you can see the PDF now. Can you see? Can you see the PDF?
Yes, sir.
Okay. So disturbance observer based current controller for a brushed DC motor. These are very, very basic, simple paper. I'm starting the introduction. There is an abstract introduction. On the introduction, we start with a very simple thing and simple model, state space representation of that, and you go for mathematics. And then it's things are getting a little bit complicated in your eyes, but so we go for mathematics. Okay, another important thing which I wanted to tell you, it's okay to have double columns utilized for big diagram like this. Look at the clarity of the diagrams, right? All of my papers are like this. Look at the clarity of the diagrams. This is very important when it comes to publication. Look at the diagrams, and even I'll show you another one. So these are very clear. These are well aligned. See, alignment is very good. So do you know how I drew all this? These are there and so on. Do you know how I drew this? Do you know what is the software that you should use in order to draw diagrams like this? I used Microsoft PowerPoint. Using PowerPoint, you can draw very good diagram, but you have to save it. If you save a diagram as a PNG or JPEG, the quality is really, really, really bad when it comes to printing. This is I actually downloaded it, and these is not the best. If you search the same paper from the IEEE, it would look better than this. Okay, I will. Can you see another one? Now a book chapter is here. Can you see it? Another.
Yes, sir.
All right. Thank you. And these are book chapter which I published. How to do it? I'm going to explain it. But just wanted to show and go. All right. I'm starting the book chapter with a. This is a book, right? When it comes to a book, things are different. So you have to have photo things like this, photos and so on. So the figure 1, human senses and stimulus, sense of touch. So see, diagrams should be very clear and these should be very sharp. So these diagrams we made it using PowerPoint, nothing else. But using PowerPoint, you have to save it as vector, image vector, so that you can scale it up and down so the quality will not deteriorate. Okay, I will show. I'm not going for technical details. Right. Now see that all the lines are in the same level. So no ups and downs. The arrowheads are there, clean, neat, and font size are the same. You can compare. So keep that in your mind when you draw. Okay. When it comes to drawing diagrams, draw diagrams which are very simple. Just look at this. What I'm going to tell is, can you see this figure number 4 now?
Yes.
In this figure, what I'm going to tell is, now there is an operator, there is a person. Person is pushing an object, or he's touching an object. So when he's touching an object, he's getting a reaction force from the object to the human. So action is there, reaction is there. So that now if this process is to be done remotely, What are the things that should be there? Now, if this to be done remotely on the user side, we call the master side, the hand should go here, and hand should be interacting with the robot arm, so that the person should feel as if he is pushing the object, so that the this robot arm should give you a feedback as if he is touching the object. And on the remote side, there should be a robot arm. Robot arm should be touching the object, so that you should get the same feeling. So this is called bilateral teleoperation, which is my PhD research area. But so that is the idea, right? That is the idea. That idea is a complex idea. So if this is to be successfully transmitted, if the touch sense is to be successfully transmitted, yeah, things that should be like this. So don't be afraid to draw this type of cartoon like diagrams, because that conveys the message very clearly. Okay, I'll show and go, and maybe I'll show one video out of this. The mathematical equations are there, and those things I'll skip. The big book chapter, but I just wanted to show you the diagrams only. See the diagrams? Diagrams are big, and it should be clear. That's it. So, and these should be sharp, because that's why I told you all these were drawn using Microsoft PowerPoint. In the PowerPoint, we group everything, and finally you right click it and save it as a EMF file, meta file, so that you'll get this quality. Okay, block diagrams are very clear. I might come back to these equations later. Regarding to this, there are so many videos, bilateral teleoperation videos in my website. So since the time is going on, I might touch those things at the end of the lecture. Now we will go for the writing of the paper. Okay, now we were just able to write the topic, right? Writing the topic is also very hard. So I said you should write about the 5%. So of course, now we decided we should write about the topic. Now what we should be, how then after that, how do you assemble and how do you put a name? Namak තියෙනවා වගේ වැඩන්නේ. So we should get the consent from a lot of people, father, mother, and so on. So just like that. Now these days I'm putting a name for our new journal with one of my students. So what we discussed was, so we are just putting several options. I don't know whether he's here today or not. We are putting several names in the sense we just propose one. I'm just proposing one. Another student might be proposing one. That's how it goes. And then how do you propose a title? So it's very hard to propose a title. So my guideline is, number one, what you should be doing is you should jot down the keywords. What are the, so if you just write several keywords: bilateral teleoperation, sensorless control, robotics, motion control, and so on, you just keep the essential keywords. Write the keywords. Once you written all the keywords, then think about this 5% and then assemble it and make it a topic. That is how you put the topic. Still we are at the topic level. We just made the topic. Okay, right, next. Now we have to write the paper, right? Now we created an idea, and from that now we have to write a paper. So let's take a paper. So how do you get a paper format? If you want to write a paper formats are available in respective journals or conference papers. If you go to IEEE website, or if you just search in the Google as IEEE conference IEEE conference format. You will get a PDF. In that PDF itself says it's written in the format that we have to use. But the PDF itself, PDF or the Word file is also available. Word files tells you, so it is formatted in the way that you wanted to have the paper, and the paper itself tells you how to format the paper. So there are guides like that. You just have to read it. So there are regulations for font sizes, names, and so on. I'm not going to touch those things. I'm going to touch about what to be written, right? Okay. Now we have a prestigious name. Now you can change the name later also. So what's next? What's now? The name should be there. Author affiliations, addresses, and so on will come here. What's next? මොකද්ද මෙතන? At least type. You are lazy now.
Abstract.
Abstract. So abstract abstract is there, and after that there is what you call keywords. So keywords now you have already decided keywords because you are having the idea of the keywords, right? So using keywords we put the topic. Abstract, my golden advice is don't write the abstract now. Don't write the abstract now. Do it later. Now let's assume that you have 2-column format, and the next thing is you are starting with the introduction. Okay, you are starting with the introduction. So what to be written in the introduction? So now you have studied theories. I will catch Professor Buddhika and others. Tell me what to be written in the introduction. What to be used in the introduction? Is it literature review or not? No responses yet. And I'll say, now there is a very clear difference between abstract and the introduction. So abstract and the introduction, is it clear to you? So you might be having problems with abstract versus introduction. And this is, I think, fairly clear, but abstract versus conclusion. Can you differentiate? Maybe going with right. The first thing is abstract versus introduction. Abstract is either what I say is abstract is a marketing statement. Marketing statement means now I have a topic. Now I have a topic, very good topic. Now abstract is to, because now my target by in writing a paper is to get the reader and get the reader to go through my paper as much as possible. Why? It's good for me for the reader to read this and understand. If he reads it, he will use it in his research so that my rating goes up. So that abstract is like the face is actually at the topic, but this is the maybe second phase, right? Maybe in the nose. In the abstract, what you do is abstract, you elaborate, or you just say, if you read this, these are the things that you are going to know. This is what we did. These are the things that you would like to know, and these are very important, and this method is very clear, and this is a marketing statement. This will this is not a summary, this is not a conclusion. So that is the difference between the conclusion. Conclusion concludes everything. We conclude everything. But abstract, keep that in your mind. Why we write an abstract is this is to introduce you to the topic. It's not actually the introduction, not the introduction, but so for those who read only this part should get a clear idea what is being done here, And why this is important, so that this is a marketing statement, just write clearly as much as possible, and everybody reads the abstract. If your abstract is attractive, people will read on. So marketing statement is very good. So in the paper which I showed you is was not that good, right? So in my first paper, it abstract was not that good. It was very short, but abstract is one of the best part of your paper, a research paper or whatever. So you have to write it very clearly and try to attract the person, and try to give what you would be expecting in reading this. So these are the things that you will see, that this මේක තමයි, this is like kasakaru, right? So this is, you once you present this is what you are going to expect. So write it very clearly and concisely, and it should be well presented. All right. When it comes to introduction is you introduce to the topic, but abstract is, it's everything, but it's a marketing statement. Conclusion is you conclude it, you conclude, and those are the problems and so on. I'll explain this later. But abstract, don't write at the beginning, right? You start the key with the keywords. Maybe you can place uh, you can leave a space here and start with the introduction, right? When it comes to the introduction, then there is a, then where do you put your literature review? Is it under literature review, or is it a separate area, or the same? I'm talking about papers, technical papers. Okay, one literature review for introduction. Yes. Yeah, normally when it comes to papers, literature review is placed within the introduction. So, okay, I'll elaborate on that. Thank you. Why we do it is, we are now going to make a funnel. Funnel කියන්නේ පුනීලයක් හදනවා, right? I'm making a big funnel. Okay, here it is small, here it is big, right? That's the idea. Okay, now this is funnel. This funnel is my introduction. I'm talking about introduction. This introduction, you start with some remote thing, but okay, I'll show you several examples. These are not very good examples. I'll show you my first one as well. Okay, I don't know whether you can see this 17.pdf. 17.pdf. Can you see? Yes.
Yes, sir.
Yes, sir.
Okay, thank you. Okay, now see the first statement. DC motors are used in wide range of applications, ranging from small toys to locomotives. That is the first statement. DC motors are used in wide range of applications, ranging from small motors to locomotives. 1 and 2. Now this is very important thing, 1 and 2. So when you put the references should be placed in the it should be increasing, 1, 2, 3, and so on. You should arrange it like that. And normally it is very good if you can put the reference at the end of the statement. Now here, look at here, right? And I'll show you another one. My first paper. First paper is not that good. In this paper, now see the problems. In this paper, so abstract. In this paper, traction control method for two-wheel is presented. It's okay, but this is very short, and this is, I don't see much of a difference between introduction and the abstract. Abstract is weak here. Abstract should be strong. Okay, how I started the introduction. Today, the electric wheel manipulators are extensively used in outer space experiments and places where engine driven option, blah 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 blah, and it goes on, right? So that here I'm putting a statement. Okay, I'll go back. Now I think you already understood what I wanted to tell you. Here I'm putting a statement now here. So introduction, first sentence. Introduction, first sentence. I have to write a sentence which is not too far as well. It should be related to this, right? It should be related to this, but it should not be too far. So you start with somewhere where you wanted to, and maybe in the first statement it's okay to use a reference because you are quoting some a generalized statement here. First statement is should be attractive. It should be a generalized statement, should not be redundant. Redundant කියන වැඩ නැති නිකන්. So nowadays, for example, let's say now I'm making a mobile robot. First statement I say, nowadays electrical vehicles are becoming popular. Everybody knows that, right? Don't say that. Don't waste your precious space. What you should be talking a little bit relevant thing. If you say in for example, the percentage of electrical vehicles in 2020 was this much, that is a better statement than that. And then you can cite, you can refer to a document where you got that. So that's a better statement, that better attractive statement. The first statement. First statement is very important in the introduction. So you do not start with a very remote idea, but start with the idea which is eye-catching and so good statement where you can really introduce you to the topic. Now you started saying this, and as you go on now, this funnel, see this funnel, it's becoming narrower and narrower. What I mean by that is, first of all, you talk about the research which are totally far away. Totally far away. Here you talk about the market of EVs, or how the market changes. But as you go on in the introduction, at the latter part of the introduction, you should be talking about, let's say, I'm talking about enhancing the wheel slip of EV. Enhancing the wheels are slipping. So let's take my topic for example, enhancing the wheel slip of a mobile robot. So there at the end of this, I should be here. I'm talking about this right here. Just before at the end of the introduction, I should not be talking about the market now. Here I should be talking exactly the competitive research that others have done, and uh, which are giving an edge to me, and you should be able to compare with their work. But these people, ABC et al. Or Abekon et al. Have developed a system like this, but they have not done this, for example. So that is a statement that you compare, and you just critically evaluating at the end of this, at the end of the introduction, you are critically evaluating the literature, and you say that they have not done that, and so on. And okay, now what is to be written here in the middle? Okay, the first one is a generalized statement. Last bit should be a comparison with what others have done. This last part, what others have done in doing this, because now I'm doing this 95% and 5%, right? So then if this to be cleared, I should talk about this 95%. I'm basically talking about this 95%, and there may be research which are very clear to this 5%. So I'm talking as you go on, that last which are very near to your work should be stated at the end of the introduction. Okay, the first statement is clear, last statement is there, clear. Now the introduction, what is to be written here? Okay, introduction, of course, it should be an introduction to your research. So you are basically presenting what your research is about. But you should not go for big mathematics in the introduction. So no big mathematics, just introduce and go. So you can handle the mathematics later. As you go on, right? All right, as you go on now you're at the introduction, middle of the introduction, right? Here we are, and the first part is finished, and the middle of the introduction. We are basically dealing with literature review, right? You have done a assignment on this. What if nobody talks? Is this the way that you normally behave? Should be okay, right? I don't know. I don't know you. Okay, literature review. When it comes to the literature review, why we really review the literature? Why we use literature? एक बात कहना बस. Why do you use literature? In order to do what?
In order to find about the past researches.
Yes. Anything else? Okay, this is my list. We okay, there was another. Right, good. Justify the novelty. You should be talking now because sabagol නැති වෙන්න බෑනේ. You're going to be master of engineering to justify the novelty, which is very good. Okay, why we review the literature? Why we if somebody asks why I review the literature, I'm having several answers. Number one, okay, I'll write it there. Another one, find research gaps. Yes, barely you are saying finding the research gap, you're using the literature. Yes, what you say is correct. That is the most important thing in literature review is that. But let's start with why we start the literature review is basically we are referring back to my 95% 5% job, right? So if you want to write a paper on this 100%, this is the 100%, this is 95, this is 5. I ask you to write about this 5%, this 5%, 95%, right? That's what I said. This 5 about this 5%, you have to write 95%. 95% you have to write about this 5%. Sorry, and 95% only 5%. So how do you make that? In order to do that, now this is what you do. This 100% is what you do. So then 95% of the things are already done by the others. So we are using their technology, we are using their methods, we are using their algorithms. If you do so, now why we use the literature is, so the concept of writing a paper is, once you have written a paper, right, keep this in your mind very clearly. Once you have written a paper, by reading that paper, another person should be able to do the exact research from the scratch by reading the paper. If it is not, that is a bad paper. I'll repeat what I said. Once you read the paper, if the person who's reading the paper cannot do exactly what you did and repeat and check your results, that's not a good paper. That will not be accepted as good. If so, now you should be, this is 100%, right? You are using others 95%. Others 95%, you have to tell about what others have done. So number one is you should be using literature to say what others have done, and I have used. So the first idea is just tell that these things I have used. So why I say this is to convey the message that if a person wants to do this, just refer it from these papers and do it on your own. And so another idea of derived from this is, so shorten the length. Shorten the paper, because I should be concentrating on my 5%, not the 95%. So I want to shorten the paper so that without duplicating the same thing. I'm just using the literature to say, and if you want to see this, just look at this literature and read it out of that. I don't want to elaborate that, and I don't want to explain everything and so on. So that is the first idea. So what others have done, and I want to shorten it up, and I'm using that for that. So number second, the second reason that we are using literature, that is to prove something. For example, I want to say that electrical vehicles are becoming popular, and my research is also becoming popular. Will become popular because this also related to electrical vehicles. So if you want to say there should be some statistic, right? So then you say a statement. At the end of the statement, you put a number and cite a paper. That means I'm going to prove what I wanted to say. I'm using literature to prove as well. Number 3. Okay. Now literature review, the right. So prove means, so this implies everything, but I will elaborate the same thing again. So maybe I'm using a mathematical method. I might be using a mathematical method, derivation, or a algorithm. So without writing the algorithm, I will use this proof here in my case. So if you see, just say, if you want to see, just look at that. Okay, number 3 is that. Finally, now you are basically you have to put the literature in a way such that maybe this is the literature number 1. This literature number 1 is very much far away, very much far away. So as you go on, as you come down, the final literature should be very much competing with your job, competing. So competing research, you should place it at the end of the introduction. Now here you say about, basically you say about the 95%, and so you should keep this mind map in your, when you write this. Then you come to the end of your introduction. At the end of your introduction, now you are at the edge of completing. So here I'm having competitive research. When you say competitive research here, especially at this stage, you should be having 4 5 papers, and you have to very clearly say these they have done this, but they have not done this. Why you say they have not done this? Because you have something in your mind. What? You have something in your mind which you want to prove, which you want to propose. You are now going to propose something. Now you have that in your mind, and that's why without saying anything direct, you just say they have done this, but they have not done this. They have done this, but they have not done this. They have done this, but this is the deficiency of that. That method is bad. You say all those stories here at the end of the introduction. Why? You are now going to propose something, right? So then at the end of these things, once you have very clearly said everything, now I'll clear it and rewrite it. Okay, now everything is clear. Now you have your funnel back again. Now we have very clearly stated everything, right? We have very clearly stated everything which is here. Now competing stuff is finished. This part is finished now. Now you finally, now you here at the end of here, your objective should be there. Here the objective should be there. These objectives, actually you have to, how do you write the objectives? Objectives you have to derive from the introduction. Derived objectives, the story is like this. So my research is important because it's increasing, and this research, they have done this, they have derived this mathematics and so on. You come down, and then at this stage you say this paper they have done this, but they have not done this, and so on. Finally you say, and then you say, therefore my objectives are, it's very important, therefore my objectives are, therefore my objectives are means, so that now you have a very clear gap. The gap is already highlighted here. Gap is already highlighted, so that Now you don't have to you don't have to stay say the object gap again, because gap is already explained. And objective should be derived from the gap statements that you made here, so that from this objectives you should derive. Once you write the objectives, I just got your proposal, some of the proposals from Professor Buddhika, and they are not up to the mark. So I have everything, but now it's not the time to discuss each and everything. So objectives, if you want to write objectives are statements. So you have to write in as a statement number one. So of course in a presentation maybe you put number 1 2 3 or bullet number 1 2 3 and so on, but when it comes to paper we don't write like that. But there should be very clear statements. This is what I'm going to do. For example, I'll take several examples. Now let's say we'll stick in the same problem. So now let's say we are going to make an electrical vehicle EV. So I'm saying my objective is to make a high speed EV, right? Then better performance EV. Is these are okay as objectives? These are okay or not? My objectives are to make a high speed EV, which is better performing EV, high efficiency EV. Is it good or bad? Yeah, these are not good, because not good in the sense now this is like a lawsuit. So that we use the literature, we proved everything, we clearly highlight the research gap, and finally I said you have to derive the objectives. Your objective statements should be actually measurable or comparable. As soon as you say high speed, how high is that? Right? How high is that? Nobody knows. What is the better? Better performance? Better to what? So these are vague statements. These are not good objective statements. Objective should be, truly speaking, there should be measurable. There should be a target. Target should be measurable or comparable target. So here you very clearly say my objective is to make EV which is capable of, if it is high speed, which is capable of accelerating at 120 meters per second, or likewise, that's the velocity. Anyway, so you have to say very accurately what's your target, or it is better than this value. So better performance, maybe performance, it might be in terms of energy or whatever. So just say what you're going to say, but do not say that it's better performance or do this or do that. That's not what you are supposed to do. Okay, these are statements. Just very clearly say statements. How many objectives that you should be having when it comes to research? I have seen students writing objectives like this. Number one, undergraduate students, especially. Literature review, right? Literature review, making the design, or drawing, right? Drawing. And then they say prototype making. After that, simulation, and finally testing, and number 6, presenting a paper. Okay, these are also literature review, design, prototype making, simulation, testing. These are also objectives, correct? But these are actually more or less, these will fit into the, okay, I'll explain that. These will fit into the methodology, not the objectives. These are not objectives. I have seen most of you have written things like these in your objectives. Objective was derived from the literature review, and it should be measurable and comparable and evaluatable. right? Those are the statements that you should be putting at the as objectives, not these. All are wrong. Okay. Now, mm, that's also done. Any questions up to now? Anything that you want to discuss?
So I have a one
Yeah.
question about the introduction.
Yeah.
When we are using literature review, sometimes we find that there are several papers when, let's say, when we want to prove something,
Mhm.
there are several papers with that concept.
Mhm.
So when citing a literature,
Mhm.
what we are going to use is cite the most recent one, or the cite the first paper that
Okay, thank you. Right,
introduced
good.
the idea.
Okay. No, what you should be using is you should not be thinking about the recent fund or whatever. So of course, if for example, if a technology was built up, or for example, you are talking about a light bulb, right? So then if this was invented by Thomas Alva Edison, I don't know whether he has written a paper. Then if it is the first paper, you have to write about his paper, and that's okay. But what you should be citing is, if there are so many papers have so was there, it's good to use the first paper if you want. But when it comes to the literature review, finally at the end of the and at the end of the, okay, I'll draw the funnel again. At the end of the, so maybe at the thesis, right, at the thesis evaluation, if you want to prove something which several papers, several others have already proposed the concept, I will give you a trick. The trick is, so of course you can cite the first paper, that's also okay. So maybe you might be talking about the literature review happening maybe at the middle part. If it is at the middle part, there is no hard and fast rule. What I normally do is, I will normally cite papers which are already cited by the others. You can see the citations already. So normally I put the famous papers, so that's the easy method of using it. So just put the paper which is having the highest number of citations. That's safe, because that's okay, because they may be used by the others because of a reason. So that just choose, if there are several competing papers, just choose one of those. But there are no fast rule of putting only one paper. No, now normally you can put brackets like this, 3 papers. That's not also a problem. It's so easy. Just put several papers, and finally you just say everything. But at the normally, especially when at the end of the presentation, normally you are expected to write the list of uh, list of papers that you are referred references. Now when it comes to reference list, I also go through the reference list, number 1 2 3 4 up to 10 it goes, right? Up to 10 it goes. Now the reference paper list is there. These are the papers. Now when you what goes to my mind is, always, if I'm a supervisor, if I'm evaluating your research as the panelist, I check normally the years. So now this might be 2001. Another one is likewise. I'll just check the papers, and if I find the latest one is 2010, and this is about my topic. My topic is about electrical vehicles, right? Electrical vehicles. The latest one is 2010. If this happens, normally I normally used to bombard the student, because now lots of things might have happened after 2010. Why they have not prepared the most recent relevant literature? So my golden rule is, here when it comes to these papers, this level, you can put all papers, not a problem. But especially which is near to this, here this should be new. Okay, thank you for asking that question. I hope that I have answered the question. Anything else?
Thank you, sir.
Anything else?
Sir,
Yeah.
how many literature reviews do we have to follow? That means how many researchers?
Okay, good. When it comes to number of papers, for example, I'll tell you the mm, in terms of for example, for a research paper, conference paper, right, conference paper, we used to say 8 plus 8 plus relevant papers, because 8, why I say 8 plus, actually truly speaking, for a conference paper we are using more literature, but in conference papers page limit is there, so that we are normally putting most relevant 8 references normally. But when it comes to a journal, right, I'm talking about journals. Journals are normally 16 to 35. When it comes to a PhD, for example, it's 100 plus. For your masters, I'll give you a rough idea. It should be at least 25. Masters, not talking about your proposal. This is your at the end, right? So these should be, truly speaking, you should be read these. So it should be 25 plus at least minimum. But in your proposal, I don't know. So that depends on who is going to evaluate that. Maybe 6, 7 might be enough. That's what my guess. But higher the better. There is no upper mark for literature review. But when you have a big literature review, I use so when it comes to research evaluations, I'm not a I'm not a popular evaluator. You might already understood that, I guess. I'm not a popular evaluator when it comes to progress reviews. So that may be a reason where I stopped participating in your master's course as well, because people don't like to ask difficult questions. I used to ask difficult questions from the students. Students also don't like me participating in progress reviews. That's a fact. Why I do that is I pinpoint all these small problems. So that is to enhance the research quality, but some people don't like that. But so now let's say you have now 100 plus the week paper list. So I used to pick maybe 1 or 2 papers, and I asked directly, okay, from this paper, what you have learned, where have you contributed, what is the use of this paper to your work? If somebody asks, you should be able to answer that. That's a relevant question. So don't put redundant references. References should be relevant to you, right? So those should be relevant. Anything else before I move to the methodology? Okay, and now next topic which comes to my mind. There was another question. Too. Can we reference the same paper for different chapters? Yes, that's not a problem. Normally, once you put, for example, the first, let's say in the text, right, this is where I start, right? In the first appearance, you put this as the number 1, let's say, number 1, and you write it like this, right? Number 1 was already, so because normally you had to put in the number order. First one was first, second one second, third one third, likewise it goes to 50, let's say. And all of a sudden you want to use the paper number 2, let's say here. After that, paper number 2 you want. That's okay, perfectly okay. And all right, I don't know, maybe these might have already taught by the others, so don't write like this. Hmm. Tell me what is wrong. Have developed. Is this okay? Is this a good statement? In one, Abekon et al. Et al means Abekon and the others, Abekon and the clients, right? Have developed blah blah blah. In one, is it okay? No, this is wrong. You should not use. You should not use this language. And so this is wrong. Instead of saying like this, you can just say, Abekon et al have developed this, not this. So once you say this, that's so. Don't use this as a noun. Don't use this as a noun. And I have seen a lot of people in their papers and okay. Anyway, I'll tell this since it's come to my mind right now. When you write the paper, when you write the text, maybe, and if your reader wants to read the now, I read something, right? I read something, and now I am having an equation. See here, if I say as shown below, I say maybe force can be calculated as shown below. Is it a good statement? Is it a correct statement? No, that is also wrong. So some people say as shown below, as shown above, as shown below, as shown above are school time, not for technical literature. What you should be saying is here as shown in. So that depends on the as shown in fig 1 or as shown in equation number 1. Equation number 1, normally we don't put we don't say equation, we just put this bracket and this as shown in 1. Here it's okay, here it's okay to have use it as a noun, but not in this instant for equations and figures, everything. The reader is supposed to look at the figure or look at the equation or look at the table if the author asks you to read that. Until that, reader will not read your equation. The reader will not read your table. The reader will not read your, or the reader will not see at your figure until you say so in the text. Everything should be stated in the text, and then only the person will go and check the equation. No, as shown below, which is wrong. Okay, I'm deviating. All right, methodology. Methodology is what is methodology? Methodology is the method that you are going to follow. Methodology is also an important chapter. Now we have already very clearly said there is a research gap. There are objectives in the methodology. What we are going to say is, using the methodology, we are going to say how we are going to do this methodology. Or in the methodology, we are going to say that this is how I did this research. This is how I did this research. So in order to say that methodology, maybe so there are no recipe for this methodology, so that normally different people uses different things. So you just follow the logical flow of the things, the order that you have followed. I'll give you a rough idea of how you should tackle this roughly, right? So in the methodology, you will be doing different things, of course. Right. So this is not exactly the paper. So that methodology is the method that you're going to follow now. Now you have a very clear idea. What is the next thing that you do? Now you have a very clear idea. Then you take a piece of paper. And first of all, the very first thing is, I'm telling you, this is not to write about the methodology. This is a general um, advice how you should tackle, how you should start your research work. The first thing is, take a piece of paper, and this is your research, and just very first thing is write the inputs. These are the inputs. Just write the inputs and outputs. So this is the first thing which I usually ask my students to do. Write or jot down the inputs and outputs. Once you have completed this, and maybe there are relations shifts from several inputs to the outputs. Maybe from this to this, there may be relationships. Once you have done this, the second thing I usually ask is do or write the equations. Write the equations. Write the equations. Once you have written equations, you have a rough idea. Then you should elaborate these two diagrams a little bit. Uh, these two diagrams can be elaborated in two ways. Number one is you can elaborate this. If this is an algorithm, for example, you can have a logical flow diagram. This one you already know it. I'm not going to elaborate that. Logical flow diagram, and from this how it goes and so on. You just elaborate and write a flow diagram like this. If it is not a flow, but if it is not a logical flow like this, but it may be a uh, hardware based project. If it is a hardware based project, the next diagram that you should be drawing is you should be drawing the system block diagram. It's called a system block diagram. It's having actually two meanings. System block. System block diagram means what are the things. For example, signal pre-processing is there, signal amplifier is there, filter is there, and post-processing is there, and so on. So how, and power supply is the power supply, and how these are connected, right? So likewise, you have to keep populating the things, how the each and every module are connected to each other. So just draw this. These are the diagrams that you have to use it in the methodology. That's why I'm telling these, so that once you have drawn these, it's very easy to write the methodology. So once you have drawn this, maybe you may use a feedback control block. So this is a control system called control block diagram. This is called a control block diagram. This is not a system block diagram, but a control block diagram. So then if you want to do so, draw the control block diagram. I have seen students using MATLAB Simulink output, and they just copy that MATLAB Simulink output in their presentations and report. Don't do it. What you have to do is you have to write the conventional control block diagrams and then use it in your research work. Do not use the MATLAB output straight away. Okay, so just do it, and all right, then we'll go for the steps. These are the things, right? Now next topic, next thing that you have to do is, so now you have all the equations, you have the diagrams, you have a clear idea what are the inputs and outputs. Now you are in a position to simulate it. So once if you want to simulate, this is how you simulate. Right, now here you have equations. There are several options that you have to follow, that you have to have. Maybe you can have MATLAB Simulink. Using MATLAB Simulink, you can tackle most of the problems. You can draw block diagrams, you can draw circuits and so on. Then you give different inputs, different scenarios, and you just check that and get the results. You can get it plotted. Nowadays plotting software are there. You maybe you can directly plot it from the MATLAB itself. MATLAB is not a good plotting software. It's very bad. So that instead of using MATLAB, I would recommend you to, maybe if you use Python, for example, the Python plot is better. And if not, I'm using for my research, I'm using a software called GNU plot. This is a free software. There are plenty of worked examples. If you have a data set which you have to plot, even thousands or millions of data plots, you can very easily plot. It takes time a little bit, but it accurately plots. So like for tabulated data, you can have 2D, 3D, even 4D. 4D means with the color coding. You can plot a lot of things using GNU plot. So that's about plotting. Plotting is used especially in results. Still we are at the methodology. In the methodology, now we said these are the ingredients that we used, and so maybe under the methodology, we may write about some. Maybe I'm using normally modeling. In modeling, okay, I'll go back and show. Right, I'm showing you my worst paper. Worst paper is my first paper. That is which was worst. Right, this is not good. So I said there are lots of problems. So introduction is number one, right? Introduction is number one. In introduction, you can say here this is not a good paper. I'll repeat. Primary objective of this research is to blah blah blah. It says like that. It's maximum possible traction force. This is also not a good statement. This is what I told you. So when it comes to traction control, second chapter should not be. Of course, you can say it, name it as methodology, but not necessarily. So instead of saying that, but here you have to start modeling it. So here what you have to do is you are starting modeling. Maybe modeling here you can see I'm building the model, what is slip and so on. Mathematical models will be developed. Once the mathematics is finished, then you go for number three, construction. This construction is also part of the methodology. How I constructed that, what are the hardware that I used. I told you before. So once after reading this, a person should be able to do this exact research as it is. When it comes to the construction, you have to very clearly say these are the parameters that we are used and so on, everything. Here on the construction, I have not given the hardware setup. So what are those motors, how I have used, what is the robot and so on. I have not very clearly stated. Again, here I have done a mistake. Again, I am touching mathematics here, so that this is not good. After construction, I'm touching mathematics. So mathematics should be completed in modeling, and then you have to go for construction. Once the construction means the hardware setup, once the hardware is clearly stated, then you go for software. Right, that is the normally accepted method, but I have used the equations and so on. Okay, now I'm going to show you my book chapter. Right, this is a book actually, so it's things are different, but things are different. Okay, yeah, this is disturbance observing means this is a theoretical part. No, that is not a good paper, right? We will go for another one. Okay, we will go for this. It's an easy one, but there are so many other papers which are advanced and better looking, but I just took this. Right, introduction is there. Once the introduction is finished, you can put equations in the introduction, but so this is the methodology, right? Methodology is started from here, modeling and analysis. So it's optional. So if you are using some trivial equations, you can use it in the introduction. That's what I have done here. Those are the basics of motor. That's why I used equations in the introduction, but some people do not encourage that to use the equations in the introduction. So my now recommendation is you should not use equations in the introduction. Once you come to the modeling, here now you start drawing the diagram. See control block diagrams are there, equations are there. So you build the model. Now you build the model, right? These are the models that you have built, right? Right. Here hardware is stated here. These are hardware. Software is also stated there. So this is fairly old paper, but okay. I will open another paper for you. Can you see this? Extended Kalman filter based. Can you see this? Can you?
Yes, sir.
Okay. So this paper was published in while I was in Thailand. One Indian guy, two Sri Lankans, including myself. So look, have a look. See, I'm using what you call a nomenclature. So this is a description of the parameters which I'm going to use, because this paper uses a lot of variables in my equations. So at the end of each equations, I cannot explain, I cannot define each and every one of these again and again. So I'm using this table for to define everything, right? So then we go for modeling, right? So this is the modeling part. This is the modeling part. It's a big modeling part. A lot of mathematics is available. It's actually master's project, right? A lot of things. Don't get afraid right now. Okay. Results and discussions. Results and discussions. So I'll come back to that later. So here what I wanted to tell you is you have to use equations. You have to extensively use the derivations in the methodology. And if it is going to be very long, use nomenclature. Okay, I'll take another paper. Okay, development of a upper limb rehabilitation robot. These are the video which I just showed you. Now see, again I'm using nomenclature here. So this is these are lies within the introduction. On the sorry, these lies within the methodology. On the methodology, nomenclature is there, modeling is there, and I'm using I'm using the CAD model and the physical model. So these comes within the methodology. So these maybe these the design. So I'm using, first of all, I'm using a design. So this is the CAD model and then physical model. So just look at the way that I have used these diagrams, so that don't just put photographs, right? So these are very good paper. We published this extended version in the journal as well. Now see, this is not just a photograph. See, I have marked everything on the photograph itself. So don't just use photographs as it is. Right. So very clear diagram should be there, and all these are within the methodology. You have to draw a nice diagram. See how clear is it? There may be clever people than me, but I'm just telling you to learn the things. See the diagram. Diagrams are clear enough, very sharp. I'm using that uh, EMF to make this diagram, and tables are there. All right, so let me show you. Okay, this is the result. Result part starts here, right? So just before the results, so this is the end of the uh, methodology. Methodology, as I told you, you have to specify. You have to give all the specification. That is a good literature, a good paper. You have to tell to the reader, this is all what I have used, all the software, all everything you have to tell to the reader. So I'm telling the microcontroller mode drivers and so on, all the parameters you have to tell to the reader. So don't hide anything, because that is the concept. Everything should be repeatable. Okay, then we go to the, since it's 11:40, we'll go for the result. Okay, when it comes to the results, this is also good paper to show the results. So on results, what we do is we show the results, right? Right. So many graphs, as you can see here. So many graphs. This is a conference paper, right? So many so many graphs. You can see the 18 references. Okay. Now here results. When it comes to the results, what you should be doing is, I don't know whether I can annotate here. I'll go back and come. Okay, now results. When it comes to the results, these results, what you should be stating as results is having a close relationship between your objectives. Now you said there are objectives. This is my objective. The objectives were actually derived from the literature review. Objectives is there. Objectives was derived from the literature review, and literature review should be linked to the results. Sorry, objectives should be linked to the results, because what you said as objectives, which are measurable, now you measure, compare, evaluate, and so on, and then using results you are now proving that what you proposed as objectives are met and at results. Don't show anything else. Your objectives and results go hand in hand, right? So you should be able to elaborate everything which was stated in the objectives as results. On the results chapter, how you start the results chapter, don't put uh, variations like this in the first instance. Before writing the before drawing these, what you should be doing is here, before this you have to tell results may be two parts. It may be simulation results. If you have simulation results, just show the simulation results and then go for the hardware results, right? You're starting with simulation results, then you go for hardware results. When it comes to simulation results will be shown like this, right? Simulation results will be shown like this. But even before the simulation and even before the hardware results, before the hardware results and before the simulation results, you have to here specify your conditions. This is very, very important. If it is a simulation, tell that these are the parameters which are used for this, and these are the inputs which are used. And therefore, for these inputs, for these parameters, KP is 100, KI is 200, and so on. For these parameters, I gave a step response. So these are then after, so you specify these conditions, you specify, then you say for these parameters, for this input, these output. Similarly, you have to follow for the hardware also. For hardware also, you say the same thing. These are the conditions. So when it comes to hardware, it is a little bit complicated. You have to tell exactly the parameters plus whatever the hardware that you have used. Once you have said that, you can plot, right? You can plot and say this is what it is. And now whatever the thing that you draw, whatever the thing that you express should be related to your objectives. Once you write everything, all these things, now then you have to explain these graphs. Explain means you have to explain these results, and you have to keep that in your mind. When explaining, you are going to prove this is like a law. This is like a court. Here, when you prove, you have to prove your objectives. You have to write, explain this, clarify things. Maybe you can mark zones and so on. Clarify and then very clearly say, this is what I have achieved, right? So this is what I have achieved, and this clearly shows my objective number one or whatever. You don't have to say that, but this should be, there should be directly linked. Okay, since time is going fast, I'll go to the final one, which is your conclusion. We'll have a 10 minutes maybe discussion if you want. All right, final conclusion. On conclusion is different from the abstract writing. I said we have to keep it, we have to write it at the last. Conclusion is it's about the summary. So this is the conclusion, is a summary. So in summary, you say, first of all, say this is what I have done. I have done this. I have received some results. The results say this. Using results, I could prove this, right? This can be applied here. That's all. Stop at that point. Don't say this research can be so don't show the future research avenues. Just show, if it is a good research, just show that is the end of the life. This is it. I have done the research. That's it. And on conclusion, you have to say everything. I have done this, I have done this, but these are the conclusions. Maybe some people it's okay. Some people to say, some people is going to are going to say this research is having these limitations. How do you say limitations? You can specify limitations, such as, so I used I did only a simulation with these parameters, but I could not do this. My motor is small enough, and so further research should be done. Don't be afraid to say those statements, because otherwise, if it is a conference paper, there is a possibility of getting it rejected if you don't say so. If it is a journal, people might argue with you if you do not say your limitations. It's okay to say limitations and conclude. That's it. Conclusion and abstract is different. Abstract is a marketing statement, as I told you. There are some things which you say, which you write on the conclusion, will be copied in the abstract, but that is there, but in a different language. That is shown as a marketing language, because once you read the abstract, your reader is expected to go through your paper. That, keep that in your mind and write a nice abstract. That's it. So what I just explained is commonly applicable for writing a paper, writing a book, or writing your proposal, even writing your thesis. Okay, that's what I wanted to discuss, since time is going on 11:50, but we have 10 minutes time. If you have any questions, I'm happy to answer. I guess now you have already submitted your proposals. So now, if you, my target was to give a clear idea how to write papers and how to do a research. So I did not use any PowerPoint. All these experiences I shared with you is my own experience in becoming a researcher from the scratch. So there are a lot of things which I did not share really, because these things you have to gain those experiences gradually by doing it. So even after telling all these stories, my students, my master students, they write conference papers, journal papers. Then I used to cut everything and I used to rewrite it, because still they are not up to the mark. That's not their fault, because students learn on their own. So it's having a learning phase, learning cycle is there. So you have to also learn by doing it. It's so my target was not just to help you to write your thesis or help you to complete your degree, but go a little bit beyond that. At least once you complete your degree, just try to publish your paper and get it get a recognition, get a additional qualification added to your CV, so that you can sell it, maybe winning a scholarship. Okay, that's all from me, but I'm ready to answer questions if you have any questions. If not, we'll stop. Okay, we'll stop, and thank you for listening. So I don't know whether these lectures are uploaded, and there is nothing to be uploaded. I guess I just shared my experiences. Uh, if they want, maybe I'll send the file. If not, I will not. Okay, if needed, my email is harsha@uom.lk. My website is outdated. It's not Museum Morato yet. It's harsha-haptics.org. Okay, that's all. Thank you for listening.